And welcome to LADYADA.
Hey everybody, it's me, LADYADA. With me is Mr. LADYADA, broadcasting live as usual from my desk, as we do on Sunday nights at around LADYADA o'clock, which, like 9, 10-ish. And I got a bunch of stuff that I worked on over this long weekend, so it's been an electronics wonderland here. Do you have any updates or news, things you want to tell the community before we kick it off?
You can check any form of social media for our ongoing quick videos that we post. It's less than a minute. It's on Instagram, and you can put at Adafruit, or on TikTok at Adafruit. We just hit 2,000 followers on TikTok. Big on TikTok. And you could also check us out on Facebook, LinkedIn, and YouTube, our blog, and Twitter. All those places when you want to see everything. And then Desk of LADYADA is when we kind of summarize some of the stuff we've been up to. And then we also have the great search that we do with Digi-Key. This week, we're back to our normal schedule. So we have, at least Lamar and I are, we have Show and Tell 7:30, last one of the year. Ask an Engineer, last one of the year. No 3D Hangouts and no JP Workshop or JP Product Pick or Deep Dive. Those all resume in January. So you got us for the last week, and that'll be how we end out the year.
Yeah. All right, cool.
So what do you got going on this week?
All right, well, let's kick it off. Let's start looking at this 7-color E-Ink display, because I have it working right now, and I'm afraid that if I touch it, it'll stop working because it's being a little wiry. But so this is a 5.6-inch E-Ink display. You can see it's kind of thin. And whereas most E-Ink has, maybe white and then black pixels, or maybe at like the most, I think we have, y'all know, like I sell in the store, we have red, black, and white pixels. This one actually has like 7 different colors. Has white, black, red, blue, green, orange, and yellow. So it's got like a lot of the oranges and reds. It's good with orange and reddish images. One thing that's interesting is between drawings, you see this like weird pale purple effect. That's like a clearing. You have to like clear the screen by writing it to this, like, there's like a special data set that you have to write to it, like all 7s, that clears it out. But with dithered images, you can see you can get like really beautiful displays. The color is really quite nice. Lucianne designed some nice artwork for us. And then you can use the tutorial we have a guide on using ImageMagick to dither images for use with just E-Ink Display, so that you can take, because you can't like mix colors. Like if you have like a red, black, and white display, you can't mix red and black like you would on a TFT, where you have red, green, blue, and you mix them to make any color. With E-Ink, only one color can be visible at a time. So it's more like silk screening, where it's like you have different silk screen colors, but they don't really mix. You just have to dither them instead. So use ImageMagick to create these kinds of displays. And we just added support in our Arduino library for this chip. It is a little bit different than others because it has like this different bit packing. But this example, we are reading images off of the QSPI flash on this Feather M4. As of right now, the library requires you to have a chip with a massive amount of memory to manage the frame buffer. The frame buffer is like over 128K. So it's not for like a SAMD21, it's for like an ESP32 with PS RAM, or like an M4, or like a Teen-C with like a good like 150 plus K of RAM. You're good to go. This little adapter board, I can make it work. I kind of made it work with a little bit of like blue wire hacking. If I get a really big SRAM chip, I can make it work with an off-board frame buffer. So that's probably going to be the next step when I make an actual breakout board for this display. All right, so that's this E-Ink. I'm going to disconnect it. Thank you, AdaBot. You can see I unplugged it, and it's still displaying this nice image. Yay. All right, do people have any questions on the E-Ink? Otherwise, we're moving along. Moving along, I got another fine gift from one of our Chinese vendors for New Year, or Chinese New Year or U.S. New Year. This fine comb. It's made out of sandalwood. And it's got my deets on it.
There was a question, because he's coming a little bit after.
Yes. Well, let me comb my hair.
There's always a delay. Sure. Is the 7-color ink faster than refreshing than 3-color?
It's about the same.
What you're saying, it looks like
it's about like 16 seconds, but you really want to refresh it twice. You saw like I did that like light purple refresh. The documentation sort of implies that you really want to do that between refreshes. So you don't have to, but it apparently deghosts the image and makes it look a lot better. So it's 16 seconds or so, 15 seconds without that, and 30 seconds with it. Note that unlike some displays, like some E-Ink chipsets, I couldn't find any way to change the lookup table. So you can't hack this to make it go faster. Like the update program is burned into an EEPROM on the chip, and like I guess you could probably read it maybe and like mess with it, but there's like really no documentation. So the lookup table is what defines how long it takes to refresh, and it's fixed.
This was a comment, it has nothing to do with this, but it's kind of funny. I sent this to you today. Someone's saying, hey, maybe you could do a super low power version of the Magtag that would have little tiny solar panels on it to charge the battery while it's in deep sleep. And I just sent you a note. I thought, you could have something where it's like on a window, the back of it is a solar panel, there's battery, charger, and then the front of it is like, IoT, temperature sensor, and all that stuff. I'll send you a link to this a little more.
I think one thing to just be, yes, it could charge it. However, charging through a window, usually windows are really good at reducing solar panel efficiency. So, you might be able to do it. Ideally, you'd use one of our like outdoor-friendly solar panels, and then if you just plug it right into the solar charger we have, and then have the battery port go right into the Magtag, it would probably just work. You could use it as is. I mean, it's just our solar chargers are solar chargers.
Window was my idea, but
huh?
I mentioned the window.
Okay.
It wasn't this. This other version.
I mean, that's the only way. Like, you want to have the EInk display is not a good outdoor display. I mean, they do make ones that are okay for outdoor use, but like now you're paying a little bit more, and you have to like refresh. You have to watch the temperature to refresh it, so it gets a little complicated. All right. Anything else? Otherwise, I'm moving on.
Why is there a notch in the cone?
I don't know.
Someone know, I love these live streams. How long you been doing them? Over 10 years. I think.
Maybe there's a holder for.
I think. Maybe it's supposed to look like something. Maybe it looks like a little fish.
I don't know.
Yeah.
I think this is a hole for maybe mounting it.
Yeah, it hangs on something. I think there's a couple things that I would. I actually already know the answer because no one will say it. I think like we're the longest running electronics show like on the internet. BN. And I also think you're the #1 female developer with the most open source repositories on GitHub. And I asked an executive at GitHub, and they wouldn't tell me. So when someone doesn't tell you something in a big company, the answer is yes. It's kind of the default. So,
I have a lot of repos, so yeah.
So I was like, hey, like you guys are doing this like, like getting more folks in tech. Like, can you confirm this? Because it's a cool like milestone. Like there is a woman programmer out there, and one of them has the most open source repos. Who is it? I think it's Lamore. Anyways, 10 years of shows, and I think we have the most repos.
All right, great. Moving along?
Yeah.
Okay, great. Okay, next up, I got these SD on a chips, SD card on a chip. So let's go to the overhead. Oh, it's already there. So these are called XT-SD04. They come in a couple different sizes. And what's neat is they're SOIC sized, but they're much higher, they have much higher storage capacity than SPI flash, which is NOR-based. These are actually NAND-based flash chips. Look, I mean, micro SD cards are not that much small, not much bigger than these. But what's nice about it is this is like surface mountable, whereas normally with SD cards you'd have to have a socket and then like the separate SD card. And that's great when you want to go move it and then you put it into a computer and you can like move files around. But if you're looking for mechanical stability or size, like this is pretty small. It's the same size as a wide SOIC. It's got SOIC spacing, so you can kind of use the same footprint. It is not, however, the same pinout as an SPI flash, which I found out, of course, just as I was wiring it. I was like, oh, I'm going to use oh, wait, nope, it's not exactly the same. So it uses a slightly different pinout, but I just soldered it onto this little breakout board, and here I've got it hooked up to a Cutie Pie. And I just connected it to the SD-FAT library that we use. which is written by Bill Grayman, and we made a couple hacks to it, and it works great. So let me go to the computer, and I can, let's see, let me reset this. Okay, so this is the benchmarking test, but you know, when you start, it does tell you it's a 0.5 gigabyte, it's FAT16, it's XTSDA, it was made in 2013, although I think that's probably not true. And then with SPI mode, you know, especially on the SAMD21, which uses only 12 megahertz for SPI, and this can go up to 50. The chip is rated, it says in the data sheet, which is like only like 2 pages long, that it's basically class 8. So I think if you wired it up to SDIO, you could get 8 megabyte read. Right, I don't know. It does have a NAND controller inside, so what's nice about it has wear leveling. So that's one benefit over SPI flash. Now it's a couple bucks, but if you're going to get into those like SPI flash chips that are like 32 megabytes or so, you can just jump right to this size chip, which is the same size, wire it with SPI or SDIO, and you can get, like in this case, 512 megabytes that's like NAND managed for you.
Is there a socket for these?
No, you would solder this right onto your PCB.
Okay.
Okay. So yeah, just doing the basic test on the SAMD21, we get about 260 kilobyte per second write, 400 kilobyte per second read. I think with SDIO, which we do have a library for SAMD51, but you have to use special pins and it's a little more complicated. You could probably get like 4 or 5 times that speed pretty easily. So, pretty cool.
Do we sell those breakout boards for various SMD components?
Yes, we do. They're just SOIC breakouts. We have TSOP and SOIC, QFN, QFP. Okay, great.
Yeah.
All right, so that's another fun thing I'm hacking. So I'm designing a breakout for this that will do level shifting, and I'll also design a version with SDIO.
150 or 200 mil? I don't know.
Check the data sheet for the exact
Yeah.
dimensions. I'm not going to... Whatever I say, it's going to be slightly wrong, so I'm not going to bother saying
Yeah,
it.
so for this, because I saw some of the questions about it,
Yeah.
why would you have this instead of an SD card that you just pop in and out?
Because it's more mechanically stable and smaller.
All right. How is its speed compared to a class 10?
It's
SD
class
card?
8, so
Class
it's
8. There you
2
go.
less.
Got it. Why would you want this?
It's just a very small data logging chip, and you can use existing SD card libraries that exist for every platform.
Got it. And then I heard that there's something called eMMC or something that someone did
Totally different.
sometime a long time ago that's different, identical, but I thought of this, but I never told anyone.
It's completely different.
Okay. I think those are the main questions.
Okay.
That not in our chat, but when
Yeah.
I was posting this around. I think this is really neat because this will mean we can get a lot of storage, use the same library, and do something like a Super ADA logger.
Yeah.
It'll be cool.
All right. So.
All right. What else do you want to show?
Next up, last before I get to my design is I got these like cool like ultra low cost Bluetooth sensors and this E-Ink clock. So this is like a little sensor that it has a little Bluetooth chip inside of it. And I even took this apart, and it's got like an ultra low cost. It's probably a Cortex M0. The part number is like insanely small. Let's see. It's a TLS-R8251, and these are like Xiaomi or Mi Home Bluetooth transmitters, and they're like only a couple bucks. They're pretty cheap. It has this. It's got like a little enclosure that you put together, a little mechanical spacer, a back piece runs off of a coin cell battery, and then there's a TFT. Oh yeah, that just uses like a Z Connect gasket to press on, and that's how it displays the basically temperature and humidity. What I thought was interesting about this is like I wanted to add CircuitPython support for these because these are really cheap and you can kind of just put them everywhere, and they advertise over Bluetooth. and a Raspberry Pi or an ESP32S3 when it when that chip comes out, which has Bluetooth, or NRF52840 like a CLUE would be able to read these sensors using CircuitPython, just listening for the advertisement. And I thought that would be kind of neat because it's a really like you're not going to be able to hand make something better than this. This is kind of as good as it's going to get. And then there's like some humidity temperature sensor here. So for just ease of use, these are pretty nifty. So these are Xiaomi Bluetooth and temperature sensors. So you can pick them up like on eBay. I got some. And then this is a EInk clock, which is similar. It has, it's totally destroyed now because I didn't realize you open it from the front, not the back. And well, I learned my lesson. So this is all cracked up, but this is an EInk watch, so you can see it still has the last thing that was on it. Also has temperature and humidity. And this is a little bit more advanced. It's got the EInk Display, which is not like a bitmap display. It's a segmented EInk. So you can't make it display whatever you want. It's like an LCD. All of these segments can only be turned on or off. There's a limited number of segments. And then inside is, I think, a dialogue Bluetooth chip down here, 2 AAA battery holders, and it's actually got these like little metal contacts for capacitive touch. So kind of cool. And then there's 2 embedded magnets. So this is a neat little, I just Googled for EInk Bluetooth clock and picked this up. Only thing about these 2 things, I will say the clock, both of these things, if you're going to use the Mi Home app on iOS, you have to set your zone to be in China. And then you can't set, you cannot set the time for these. This is the one thing about this clock. That's why I took it apart. You have to set the time over Bluetooth, but when you use the app, you have to set your locale to China, and then you can't set the time to your time. The time is set to some time in China. You cannot change the time zone. So I don't know, design is pretty cool, but missing that little piece of user interface where you could set the time without using a special app, and you can set the time to any time you want. They didn't decide that was going to be something you could do. But these little Bluetooth sensors are great because you don't have to set the time, they just emit data. Pretty sweet. So some cool stuff. So I'm thinking of doing some projects with those. And then finally, finally we're going to get to the electronics design. So to the computer. So folks know that we had this CLUE board that, here, I will go to Adafruit in case people don't know. So we have the Adafruit CLUE, which we designed basically exactly a year ago, Phil. I don't know if you remember, 1 year ago.
Yeah, we
in the before times.
We emailed the microbit folks and we said, hey, is there any issue doing microbit stuff, microbit shape? And they're like, more the merrier. We're like, right on. And so we said, cool, because we didn't think that there was going to be an update to microbit, new chip, new features, new anything. There'll be some small changes, but that's pretty much going to be like that for a while because educators are don't ever change anything ever. We bought these for our classroom. We have printouts.
Yeah.
You can't change anything ever for all the history of time. So we were like, well, there's a lot of people who have accessories, and there's a lot of people like this form factor.
And we wanted to use the NRF52840 and have CircuitPython.
So I remember I think it was Hal who was there at the time. He's like, yeah, more the merrier. So we're like, right on. And then we released it. And so far, so good. People really like the fact that they can use the microbit accessories. Some people are familiar with the shape, and then for some students, they're like, I have a microbit, but I kind of maxed out the things I can do. This is the next step. I can put Arduino on it. I can put CircuitPython on it. I can do all sorts of things with it. So, CLUE.
I know. It's cool. So this CLUE is on the back, jammed with all these sensors. It's got a STEMMA QT connector, micro USB, reset button, battery, buzzer, humidity, temperature, barometric pressure, gyros, accelerometer, magnetometer, and microphone, as well as a NeoPixel LED, and then of course on the front, all these pads that you can connect to. So with the new ESP32S2 Mini that came out, which is a little mini module version for the ESP32S2, we were like, okay, cool, we can finally make a Wi-Fi CLUE. So maybe I'll turn off the back layers. Hold on. Make this a little more visible. Whoops. Okay. So it's still being routed, but this is the new back of the board. So this is the ESP32S2 Mini. And there's only one thing, which is I couldn't fit this into the edge and also have the stem QT in the same location. And I can't really move the parts up here because I wanted to maintain parity with the CLUE, but also the microbit, which has the micro SD and the reset. And not that it would work with any cases, but it does, like, you do want to have it be as close as possible, so like most functionality is the same. So what I did is I backed off the module a bit, so you can see the module is set back. Now you're probably wondering, okay, well, why didn't you just, I can't change this part because I've got, that micro USB, I've got the reset button and the battery. Okay, so I can't move those. I need this slot to pass the screen through, and then the screen connector has to go here. So basically everything from this side over cannot be moved. This is fixed. Like the sensors can move around, and like I can move the buzzer if I really wanted to, whatever, but I can't move like anything on the right side. So the next question is, well, okay, you could put the module like this. And I actually did think about that. Like, what if I have it so the module is sticking out, not past the edge, but like, like here, right? Because that's still, you have plenty of space, and then like, the stem is here, and you get a little cute logo or something, or, you could put a sensor here. Why not do that? And I actually thought about it, and I decided when people are holding the CLUE, their hands are on the buttons, which are on the front here, and their fingers would be right over the antenna. And I didn't want to like really mess up the like antenna strength. Like I'd rather have the antenna kind of be over in the corner and like give it a large groundless space and have the module be the thing that people put their hands on. Because like once people start touching antennas, like humans are wonderful bags of salt meat, and we're really good at absorbing RF signals, especially when we're like touching a bare PCB antenna. So kind of the trade-off I made, it would have been more beautiful, more elegant the other way around. Another thing is eventually I could use a module that has a UFL connector, and then like, I don't know, maybe there's an antenna pin or something instead. But, I kind of just was like, this will fit. And it's not the most elegant, but I think it'll work just fine. Like as long, I'll just clear out this ground plane. I'll give it a nice big ground plane here. I think it'll work much better. And it's there's this connector, but this connector isn't metallic. This is a plastic connector. And I'll just make sure that this isn't grounded here, and I think it'll be fine. So this is the Wi-Fi CLUE. So I routed a bunch of pins. And, oddly enough, actually, even without pin reorganization, renaming, like the microbit pins and the ESP32S2 pins, like matchy-matchy, which was kind of nice. I always like that. Like D5 is like pin 5, and like D15 is pin 15, and it's like, oh, yeah, that's kind of nice. So that wasn't too bad of a route, and then I'm just going to, like, fill in. You see I've got some parts here and here I just have to fill in. I've got this magnetometer, which I have to put as far away as possible from the buzzer because the buzzer does affect the magnetometer. So I can put it here, or I can put the magnetometer over here. I'll probably put it over here, across the ways from the buzzer as much as possible. And then all the other pins were routed. I've got the high-speed SPI connected to the TFT, so that's good because these TFTs, even though their datasheet says 10, 12 megahertz, you can totally push them at 80 megahertz, and like they'll take the abuse, which is always fun because you can do like over SPI like ultra high speed image updates, which is great for CircuitPython because we like to do display I/O projects which require a lot of TFT writes. So the one last thing as I was designing this was one of the cool things about the ESP32S2, which I totally like, is that they have a ROM bootloader. I'm a huge fan of ROM bootloaders, Atmel, because STM has them, and NXP has them, and Espressif has them, but like some companies don't have them. Microchip. Whatever. But the ESP32 does, so let's take advantage of it. What's nice about the RAM bootloader is no matter how screwed up your board gets, and like students do all sorts of crazy stuff to their boards. They like write while they're reading, they like crop the flash, they whatever, because there's a lot of easy ways when you're like writing code to, I don't put any flash protection on. I let people write to anything. So it's really easy to like mess stuff up. With a RAM bootloader, you could always get into this USB bootloader and you can always erase the flash completely and load new code, and you're like back in business. Great. But the problem is that to get into the RAM bootloader, you need to hold down a pin, like a boot 0 pin, while you reset or power up. And I really didn't want to put another button on because I already have 3 buttons. I've got the reset button and I've got the 2 front buttons. And I was thinking like, oh, well, I could have like one of those buttons, like, oh, like why not have one of those buttons be the boot button? The reason you don't want to do that is I didn't want to make it too easy. I didn't want it to be like if you held down the button and reset it. I want it to be like you have to do 2 things to get into the bootloader. And second, the GPIO for the buttons is brought out to the edge connector, so it would have been too easy for people to accidentally like mess with this pin and like put it into bootload mode, on reset without meaning to. I don't want to make it easy. I want to make it purposeful when you want to get to the bootloader mode. So what I thought was like, well, how about I make it so when you hold down both buttons, right, while powering up, because you're not going to usually do that, like holding down 2 buttons while powering up a chip, like that's like you have to do 2. You have to use both hands, right? So it's like you're not going to do it by accident. And I was like, well, how am I going to do this? Because you can't have the microcontroller do it, and I want it to be like very compact and easy. And so it's like, oh, I know, I'm going to use a logic chip. I'm going to use some logic, and I'm going to take the button inputs and basically the power on reset signal, and when all 3 of them are low, which means that the buttons are pressed because they're pressing them brings those pads low, and when the reset is low, because that means you're in reset mode, that's when it will also turn on bootloader mode. But all 3 things have to happen, and that would be a NOR gate, right? So all things, if any of them are true, well, because I have to like have this is inverted, although I think I decided to have it be an open drain connection, basically. Although I might switch it around. But basically, if any one of these is not OR. So if all of them are low, then the value output is high, which means this transistor turns on, which pulls the boot pin low. Pretty sure. All right, so I'm going to get a NOR gate. And that's when I was like, you know what? I realized that I have never covered getting 74 series logic on Digi-Key, and so that's going to lead us right into.
All right.
Where in the world is that part I need? The great search with Digi-Key.
Every single week we do the great search with Digi-Key, where Adafruit shows you, specifically LADYADA, how to find the things you're looking for on Digi-Key. So this week, LADYADA is
74 series logic. Which, I think should get a little bit more love, because 74 series logic, yeah, okay, it was like invented in like the 60s and 70s, like before many of us were born or doing electronics. But, it's still really useful. It's like inexpensive, low power. It just works. You don't have to program it. There's no CPLD debugging or like FPGA hacking. It's just like, it's 10 cents. You put it in, it does the job, it does it fast, it does it right, it's reliable. Love it. Comes in like all sorts of flavors, like Baskin Robbins, 5,000 flavors. So in this case, I'm looking for a 3-input NOR gate, which will take these 3 inputs, and then, when the buttons are held down and the reset signal is low, all 3 things are low, it'll turn the output to be high, and then that will turn on this transistor, pull down my boot 0 pin, and that will put me into bootloader mode when we start up, I think. We'll build a prototype, but I'm pretty sure this will work. So here is a NOR gate. So, there's a lot of good tutorials online if you don't know your NORs and your NANDs and your XORs, because you can get like every kind of logic you could possibly want, including counters. But once you know what it is, you're probably like, well, what kinds of logic can I get? And like, kind of, there's dozens. And what's interesting is there's actually like a logic to it. There's a logic to the logic. In this Wikipedia article, because I was wondering, like, is there any logic to the numbering and the naming? Because I kind of never thought there was. It turns out there is. You can use this table to see the different inputs. You can have quad 2 inputs, so you have like 4 gates with 2 inputs each. You can have triple 3 inputs, so 3 inputs with 3 gates, so you can do like more complicated combos with 1 chip. Schmidt trigger input versions, open collector versions. What's interesting is for the NOR gate, remember I said I wanted to have an open collector because I don't want it to, I wanted to be able to pull high and then like mess with the chip I wanted to be able to pull it down if I needed to while programming it in the factory. So the NOR gate triple input open collector doesn't seem to exist. There's the triple 3 input. Not every combination will exist, but there are all these different versions. Now, when I'm buying 74 logic, though, I will not actually look at this table. I'll just kind of know how many gates I need. I'm like, oh, I need like 5 inverter gates, or I need 6 buffers, or 8, switching bus transceiver, whatever. And then I'll actually just search on Digi-Key and find the part number, just because I will not be able to memorize this table. And also I'm going to be looking at the package, not necessarily how many pins there are. Like, there are some times when I will use a chip that has more logic gates than I need because the package is in a convenient shape and size that will work well. There's also different families. So there's the part number, right? Like how many gates and how many inputs, and is it open collector, and is it NAND or a NOR, or what combo it is. And there's also the family of chips. So originally, the family of all these chips was bipolar logic, which was easy and simple to manufacture in large quantities in the 60s and 70s. And they had, I think I see 74 LS sometimes once in a while. But in general, you don't see people using the bipolar logic. It sometimes, if you need like really high voltages, maybe you would use it. But I only see this in old equipment. People don't really use bipolar anymore. Why? Because CMOS is much faster and lower power, and with the really good ESD protection we have these days, you don't have to worry about like smashing your logic chips with a little bit of ESD. It pretty much doesn't happen anymore. Like, unless you're like one of those really staticky people, just take some reasonable care and you're probably good to go. So that said, I have seen like a real wide variety. So there are some cool ones like 74 LV series. So these are 5 volt tolerant inputs. So I really like these as level shifting because you can have 3 or 5 volt input, but then the outputs are 3 volt logic. There's also, low voltage ones. There's ones that go down to 1.6 volts, 2 volts. There's high speed, different tolerances. There's ones that like are compatible logic level. I don't know. So I use like 74HC and 74HCT kind of the most. The T is kind of nice. It's transistor level logic, which means you can have very low logic levels and it will trigger. It doesn't trigger at halfway through the VCC point. It triggers like at like a volt or so, closer to bipolar logic, gate threshold voltages. So which one to use? I mean, sometimes you don't have a choice. Like, I'll show you for this particular chip, there was really only one family, but then you might want to look up the family to verify that this is going to have the logic level you need and the speeds you need. For the most part, you don't, unless you really need something that's a specifically low voltage or specifically, high voltage or specific speed, you can kind of go with almost anything. But when you need something specific, go here and check it out. Also, these are kind of cool. There's the high output current ones. Those are kind of cool because you can like drive LEDs directly from them. All right, so let's go over. And there was a whole segment for logic gates, but like I said, when I was looking for this NOR gate, I didn't like figure out the part number. Like I didn't look in the panel and say like, oh, it's a 74 blah 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 125. I just like typed in what I was looking for, and then I used the search boxes to narrow down what I was looking for. So in this case, I just looked for NOR gate, which is super great. And then there's a couple like kits, and of course there's gates and inverters multifunctional configurable. So it's like a CPLD, or sometimes there's like little mini logic chips that you can configure. Those are going to be more expensive and complicated. We're going to go with just the plain gates and inverters. So let's go with active ones and normally stocking, just so we can look at what's normal. So yeah, you can see there's this like 74 LS, HCT, AUP, AXP, HCU, LCX, VHC, who knows, tons. But let's just go for what I want to do, which is a 3-input NOR gate. So I want one circuit, although I might do 2 just because like sometimes you can get them in like dual and it's cheaper or easier to get that package. I want 3 inputs on the NOR gate. And you see there's only 13, hold on. There's only 13 available. Like when you're looking for a very specific thing like that, there's not going to be hundreds and hundreds of options. So then mostly it's about the package. And what I really like about 74 Logic is they have this, and this is why, by the way, I never type in like 74 HCT 125 or whatever. Even if I kind of know the number, if you want to type in like 74 and then 127, like you want, like there's no way to put in a star to match any of the families. And there are so many families, and that one might be in stock that is close enough to what you need that you can use it, because again, some might be a little bit faster or maybe have a wider voltage input, but for your use case they could be compatible. So when you're searching, just like unless you really need just the HCT, then put that in. Otherwise, I would go here and then find the one that matches what you need, and then look at the family. Like what's your power supply range, for example. So right. So let's look at package case. So I kind of want like a SOT 323 or maybe an SC74 or SOT 23.6. I don't want an XDFN. These are like really tiny chips. I want something easy to pick in place. All right, so that gets rid of like half of them. And then you can look and you can see that there's actually, they're all kind of named the same thing. Like I said, 74 LVC, 1G, 27. The 1G, I think, stands for like one gate. It's like you get a chip with one gate in it. And like, honestly, oftentimes you just need one gate. Sometimes, I'll have a buffer chip. And just I need one pin to be buffered because it's supposed to be tri-state. It's not. You can make it into a tri-state with like a selectable buffer. So in this case, these are all going to be pretty much the same because they're all the 74 Logic, and they've got like 27 is the part number. This is the only one out that's on semi, uses a different, I don't know why they call it something different. But what's nice is that these are all generic, and there's lots of them in stock, so you can kind of pick any of them. I think in the end I went with the Nexperia one. And it's just a TSOP, SOIC, not SOIC, SOT 23.6 shaped basically. And they're like 10 cents. And like this could really solve my problem. Very, very simple. And then you can see the series over here. You can see in this case, you can only get LVC for this chip. And LVC, let's go here. LVC is low voltage and 5 volt tolerant inputs. I mean, that's perfectly great. I'm using everything at 3 volt logic. If it's tolerant, goody for you, right? But I don't really care. And it's plenty fast, and it's small and easy to place in my design. So here is the chip right here. Nice small, and this is the SOT 323 package I picked up. And it's very simple. It's got 6 pins, 3 inputs, 1 output, power and ground. And that's the story. Very easy. So we're going to try this out. I'm going to see if this hack works. I hope so, because I really want to avoid putting a button onto this PCB design.
All right, that's a great search this week.
Where in the world is that part I need? The great search with Digikey.
Okay, a whirlwind. Oh, good.
That's our Disco
That's what I got. I know, I showed everything then.
All right.
Thanks, everybody, for tuning in. We'll
Yep.
be around on Wednesday. We're going to do our end of the year show and tell. Ask Engineer. Don't forget, other folks are off this week for a well-deserved rest. They'll be back ready to stream, build, 3D print, hack, code, and more in the new year. But we'll be around this
All right,
Wednesday.
we'll see everybody this Wednesday, 7:30 p.m. Eastern Time, then Ask an Engineer, 8 p.m. And you'll see our videos and more all throughout the week.
All right, thanks, everybody.
Thank you, everybody. That's this week, just LADYADA.
Bye.